there's a better way to do these things. Anyone know what we should do next?
Make a constructor.
Make a constructor. See, we don't want this client code. We don't want main to really have direct access to all of this data. We want this data to be what?
Private.
Private. If you don't say it, it's automatically public in Java. Now, some languages it's opposite, but in Java, that's what it is. So when I make these private, watch what happens. Oh, you know what? Okay, I forgot about that. All right, I need to do something real quick. We're going to make the horse class a separate class, and this one is going to be class driver. So, okay, so what I have now is I actually have two classes in the same file. This one is what's often called a driver class, and it'll usually contain this public static void main. The reason that thing I was trying to do did not do that is because main was still a part of that horse class. Now this should break. There we go. Okay. Well, let's look at the error. What is the error message showing? Name has private access in horse, and it's pointing to this code right here, joe.name. Legs has private access in horse. All of these have private access, which means you cannot do this anymore. You have to find a different way to give that information. So what we need to do is we need to send this information through the parameter list instead of assigning it out here. And then same thing with tank. The only problem is we've not defined a constructor that will take this, which is what we need to do now. So we are now defining a constructor. This is the next logical step in the learning process of how to define a class. Is we first define attributes, and then we accessed those fields, those instance fields, by giving them values, by outputting values, and then we controlled the way it looked. And now we're going to go to the constructor. How do I define a constructor? Well, it's very simple. You just simply say public horse. You don't say public class horse. You don't say public static or give it a data type. You just say public horse. Now, the fact that we're sending information here, we're passing this information, these are actual parameters, means we need to do what in the constructor?
Make formal parameters.
We need to receive it with formal parameters. So we need to match exactly each one of these pieces of information. So what type of information is Joe?
String.
He's a string. Okay. What type of information is 4?
Integer.
It's an integer. What about 2000?
Double.
It needs to be a double because that's the type that we're about to send it to. Even though 2000 technically is an integer, we want our parameter to match the data type that we have in our instance fields. We want it to match this. Okay. But it has to match these parameters by position as well as by type. So what about the last one?
String.
String. All right. So now we've got the parameters set out. We have to name these parameters something. We can't just say string. We have to give it a name here because these are temporary parameters. And most often you'll just use the first letter of the corresponding data type right here. Okay. So, and that's just it's not a rule. It's just a common, it's a convention. Okay. And maybe just a style of writing. So we're going to call this N, and we're going to call this L, and we're going to call this one W, and this one we're going to call color C. Now, last step. Here's where you actually assign these values to the instance fields. So what do I say?
Name equal to N.
Name equal to N, exactly.
Same. Legs.
Legs, yes, legs equals L, is assigned L. Weight gets W, and color gets C. Now, here's where some of your students are going to try to do this. They're going to try to say Joe.name gets N, especially if you've already started this as an example. They're going to see that this is information for Joe. They want to get it to Joe. What's the explanation?
You don't want them to be specific to any one object.
Exactly.
You want these
That's
to be applicable for all the objects in the
There you
class.
go. You want this to work for Joe as well as for Tank. And it will, because you have instantiated both of them correctly here. This will work for Joe, and this will work for Tank, because they are two objects of the same class. So now we have exactly the same output, but what did we do different?
And we made it short. Basically, the coding
Right.
is
The coding is shorter. What did we do to accomplish that? What is this called?
That's the constructor.
That's the constructor. We defined a constructor whose sole job is to react to this request, this new in client code. When you see this word new, it automatically calls this constructor. And it knows it's this constructor because the compiler says, oh, you want a new horse that receives Joe for 2000 and Brown. Let me see. Oh, there's one. It matches exactly. And an object can have as many constructors as you need it to. When you start studying the string class, you'll see that the string class is defined with 15 different constructors, 15 different ways to construct a string. You could create all kinds of ways to construct a horse depending on the specifics of what you want. You may just want to give that horse a name for now, and then later on you can assign it other things through other means.